Hi, I am Dr. TV Hemlakshmi. In this video, I would like to explain how to find the critical points of the given functions on their domains. First, let us see this example. F of x equal to x power 4 minus 4x cube plus 6x squared. First, we have to find the differentiation of the given function to find the critical points. That is, differentiation of this function is x power 4 differentiation is 4x cube minus 4 into x cube differentiation is 3x squared and x squared differentiation is 2x. So it is 4x cube minus 12x squared plus 12x, and we can take the 4x as common in all these three terms. So 4x into x square minus 3x plus 3, and when f dash of x equal to 0, this 4x equal to 0 or x square minus 3x plus 3 equal to 0. From 4x equal to 0, we get the x equal to 0. That is the one critical point, and you have to find all the critical points. So we take the another next term, that is the x square minus 3x plus 3 equal to 0. This is the quadratic equation. So that discriminant d equal to b square minus 4ac. Before finding the roots, we can check the nature of that roots by writing that discriminant, that is b square minus 4ac. Whereas a equal to 1, b equal to minus 3 and c equal to 3. So b square minus 4ac, that is the minus 3 whole square, that is the 9, minus 4 into a is the 1 and c is the 3. So b square minus 4ac equal to minus 3, that is the less than 0. So that roots are, that quadratic has a negative discriminant. So no real roots, that roots are imaginary. So those are not in our domain. So that critical point x equal to 0, and when substitute this x equal to 0, that f of 0 equal to 0. That is the critical points of the given function in the first example. Now let us see the another example, that is f of x equal to 2x plus 3 by x square plus 1, and it is in the form of the u by v. So differentiation is u dash v minus u v dash by v square, and when it is the u, that differentiation is 2 and differentiation of constant is 0. So it is the 2 into x square plus 1 minus u v dash 2x plus 3 into 2x by v square, that is a x square plus 1 whole square. And when it is simplified, we get minus 2 into x square plus 3x minus 1 by x square plus 1 whole square. I have to set that f dash of x equal to 0 to find the critical points. So this term will be minus 2 into x square plus 3x minus 1 equal to 0. So that is a x square plus 3x minus 1 equal to 0. That is the quadratic equation. So that roots are minus b plus or minus square root of b square minus 4ac by 2a. When substitute this a value, that is 1 and b is the 3, c is the minus 1, we get the minus 3 plus or minus square root of 13 by 2. So that critical points are x equal to minus 3 plus square root of 13 by 2 and x equal to minus 3 minus root 3 by 2. These are the critical points. Now let us see the another example, that is f of x equal to cube root of x minus 1 by cube root of x square. For simplification, we can write x cube root of x equal to x power 1 by 3 minus 1 by cube root of x square is x power minus 2 by 3. And the domain is all real values except 0. If x equal to 0, the denominator will be 0. That function is the undefined. So the domain is all real values except 0. Now let us write the f dash of x. That f dash of x equal to 1 by 3 into x power 1 by 3 minus 1, that is minus 2 by 3, plus minus of minus 2 by 3 into x power minus 2 by 3 minus 1, that is the 2 by 3 into x power minus 5 by 3. If we take this 1 by 3 into x power minus 5 by 3 as the common, then we get the 1 by 3 into x power minus 5 by 3 into x plus 2. And if we write this term equal to 0, on this term will be 0. If we write this x power minus 5 by 3 equal to 0, then x equal to 0. But we should not take that x is equal to 0 as the critical point, because that is not in the domain. That is not in the domain. The domain is all real values except 0. So we should not take this x equal to 0 as the critical point. Next term is the x plus 2. From that term we can find that x plus 2 equal to 0, then x equal to minus 2. So the critical point is the minus 2, that is in the range. So f of minus 2 equal to cube root of minus 2 minus of 1 by cube root of minus 2 whole square. That is the critical point x equal to minus 2. Now let us see another example, that is f of x equal to e power x into x square minus 4. This is in the form of uv. So differentiation is u dash v plus u v dash. The differentiation of e power x is the e power x, and differentiation into x square minus 4 plus u v dash, that is the e power x into differentiation of this x square minus 4, that is the 2x minus 0, that is the e power x into 2x. So it will be e power x into x square plus 2x minus 4, and this we write the f dash of x equal to 0, that e power x equal to 0, but e power x is always greater than 0. This is an exponential function, exponentially rises. So that e power x is greater than 0, and this x square plus 2x minus 4 equal to 0. From this quadratic equation we can find the roots by writing minus b plus or minus square root of b square minus 4ac by 2a, that equal to minus 1 plus or minus root 5. So that critical points x equal to minus 1 plus square root of 5 and x equal to minus 1 minus root 5. Now let us see another example, that is f of x equal to log of x square plus 1 minus x. Differentiation of this function, that log function is the 1 by x. So log of x square plus 1 differentiation is 1 by x square plus 1, and differentiation of x square is the 2x. So differentiation of log of x square plus 1 is 2x by x square plus 1 minus x differentiation is the 1. When it is set to 0, that 2x plus 2x by x square plus 1 minus 1 equal to 0. So 2x by x square plus 1 equal to 1, and 2x equal to x square plus 1. We can write as x square minus 2x plus 1 equal to 0. This we can write the a square minus 2ab plus b square. So we can write as a minus b whole square, x minus 1 whole square equal to 0, that x equal to 1. That is a critical point, x equal to 1. When substitute this 1 in the given function, that is f of 1 equal to log of 1 plus 1, that is log 2 minus x, that is a minus 1. Thank you for watching.